Dear student, I am starting your lecture number 7 on a number system. Today I will discuss the first complement representation. In the last lecture we have discussed about signed binary number. In continuation of the topic of signed binary number, I am discussing first complement representation. Let us summarize the lecture number 6 of a signed binary number. To represent the sign of the binary numbers, MSB are used. See, you are knowing, in a decimal number system, plus sign is used for the positive numbers. Plus sign are used for the positive numbers and negative sign are used for the negative numbers. If sign is not mentioned, then it is called unsigned number. And unsigned number is always positive. Unsigned number is always positive, remember. Similarly, unsigned binary number is always positive. Unsigned binary number is always positive. In a signed binary number, the most significant bit is used to represent the sign of the binary number. Whether the binary number is positive or it represents the negative numbers. Whether the binary number represents the positive or negative number. If MSB is 0, then that binary number is positive. If MSB in a given binary number is 0, then it is positive binary number. If MSB is 1 in a given binary, then it is negative number. So in a signed binary number systems, MSB represent the sign. In a signed binary number, MSB, most significant bit of a binary number, represent the sign. 0 represent positive binary number, 1 represent negative binary number. In the last lecture we have seen sign magnitude representation. In a sign magnitude representation, the MSB represent the sign, 0 represent plus sign, plus binary, 1 represent the minus binary. Today we will discuss first complement representation. There are 3 methods used to represent the signed binary number. First method is sign magnitude representation. This method already we have discussed in a lecture number 6. Second method is first complement representation, that we will discuss in a lecture 7. And third method is 2's complement representation method. So I am studying here about first complement representation method. In a first complement representation methods, the first complement of any binary number can be obtained by subtracting each bit of binary number from 1. In a first complement, if you want to obtain the first complement, then first complement of any binary number can be obtained by subtracting each bit of binary number from digit 1. As for example, look here, first complement of 0 is nothing but you can write 1 minus 0. Means this is I have subtracted from 1. This 0 bit I have subtracted from 1. So my first complement of 0 is 1. That is, you can say first complement of 0 is 1. Now what is the first complement of 1? First complement of 1 is equal to, I can write, this should be subtracted from 1. It means first complement of 1 is equal to 0. So it is very clear, first complement of 0 is 1 and first complement of 1 is 0. So somebody is asking you, find the first complement of this binary number. Then I have to replace 1 by 0 and 0 by 1. Listen again. The first complement of any binary number can be obtained by replacing 1 by 0 and 0 by 1. So look here, 1 is replaced by 0 and 0 is replaced by 1. So this is the first complement, it is the first complement of given binary number. So it's very clear, the first complement of any binary number can be obtained by replacing 1 bit by 0 and 0 bit by 1. Now, the decimal number 8 can be represented in a 8-bit binary number by this way. You already know that. If you don't know, this is 2 raised to 0, 2, 4, 8. So this is 8-bit total. You can count 1, 2, 3, 4, 5, 6, 7, 8. Now, the first complement of this, you know that first complement of 8 is minus 8. So, first complement of 0, 0, 0, 0, 1, 0, 0, 0 is nothing but you can write 1, 1, 1, 1, 0, 1, 1, 1. You can check. This is the complement of this, means this represent minus 8. This represent minus 8. In short, the complement of any positive binary number is negative or vice versa. The first complement of any positive binary number is negative or vice versa. So, now let us proceed further. For an unsigned number, just for your understanding, for an unsigned binary 8-bit number, for 8-bit binary number, represent maximum decimal number 255. Maximum decimal number how much? 255. For a signed binary numbers which you are using a first complement representation if you are in a n bit binary numbers, then its first complement representations maximum positive number is 127. In a first complement representation binary number system, it represents maximum decimal equivalent plus 127. Maximum positive decimal equivalent number is 127. In a first complement representation binary number system, its maximum negative decimal equivalent is minus 127. In general, in a first complement representation binary number system, if it has a n number of bits, then it represents maximum positive number is equal to 2 raised to n minus 1 and maximum negative number is 2 raised to n minus 1 minus 1. So in a first complement representation binary number system, if it has a n number of bits, then it can represent maximum positive or negative decimal equivalent is equal to 2 raised to n minus 1 minus 1. Now let us see the step how to write the negative decimal number with the help of first complement representation. If you want to represent any negative number, say minus 27, in a first complement representation method, then first step number 1. First write magnitude of minus 27, that is what 27. I am discussing this step for the negative number. The following step you have to proceed to obtain first complement representation of a negative number. So what is the first step? You take the magnitude. Step number 2, find its binary equivalent. Third, then use a find first complement of above binary equivalent. Suppose somebody is asking you represent minus 27 in a find first complement of minus 27 in 8 bit. I am using a word 8 bit binary. So what is your first step? Find the magnitude of minus 27, that is 27. Second, find its binary equivalent. Shall find binary equivalent. Then write its first complements of this binary. Let us do that. So magnitude of this is 27. Let us now second step 2. This is your step 1. Step 2, 27 divided by 2. So I am writing its now binary equivalent. Look here. Already you know the method. I am not directly writing because for your understanding it is good. See, already we know, read up, this is your MSB, this is your LSB. So you can write step 2. Step 2 is, what is the step 2? You can say this is your answer 1 1 0 1 1. Okay. So you can see here it is a 5 bit 1 2 3 4 5, but you have to write the answer in a how much bit? 8 bit. So I am adding 3 0 here. 1 2 3 1 1 0. This is your step number 2. Find its binary. This is a binary equivalent of 27. Now write is step 3. Step 3. What is the step 3? Find the first complement of this number. The first complement of this number is 1 1 1 0 0 1 0 0. So this represent minus 27. So this represent minus 27. This represent minus 27. You can see. So this is 1 1 1 0 0 1 double 0. Look again. Just I am discussing. What are the steps to find the binary of a negative number? Binary of a negative number. What are the steps? First step, find the magnitude of the given decimal number. The given decimal number is about minus 27. They are asking you to find its binary equivalent using a first complement representation. We are discussing for the negative number, remember. Negative number. So what I have to do? I have to find the magnitude of this negative number. Then second step, find its binary equivalent. So I am finding the binary equivalent of this 27. Third step, find its first complement. This is the first complement. So this first complement represents minus 27. I think it is very clear. Suppose somebody is asking you how to write positive decimal number into first complement representation method. The binary number of any positive numbers in a first complement method is the same as sign magnitude representation method. Let me explain you by some same numerical. Suppose I want to write, find the first complement 8-bit binary in a, I want to represent, let me use over this, I want to represent plus 27 in a binary number 8-bit binary number with a first complement representation method. Answer. First find its binary equivalent. I find the binary equivalent. What I did? I find the binary equivalent. See, look here, I am finding the binary equivalent. This is a binary equivalent of a positive numbers. So binary. Write this in a 8-bit. This is what 1, 2, 3, 4, 5, 6, 7, 8 bit. So this is the, you can say 27 is represented in a first complement representation. So someone said it is also the same, it is a sign magnitude representation. Yes, it is the same. In a sign magnitude representation, the 27 is represented by this plus 27 positive. in a first complement representation, plus 27 is represented by the same way. Only for minus 27 we have discussed the previous sum. Now let us discuss the more sum for your clarity. See the questions. Represent the following decimal number in a first complement representation using a 8-bit. Represent this decimal number into binary numbers using which representation? First complement representation. So let us start the first for minus 67. Step 1. Step 1 is write its magnitude. This is step 1, you can say. Step 1, write its magnitude. Step 2, find its binary equivalent. I am writing the binary equivalent of 67. Directly I am writing it is 1. Binary equivalent of 67 is 1 0 0 0. This is a binary equivalent of 67. How much bit? You can see here. How much bit? 1, 2, 3, 4, 5, 6, 7. What I have to use here? 8-bit. So I will write this is in a 8-bit 0, 1, 0, 0, 0, 0, 1, 1. What is the first step? Find its magnitude. What is the second step? Find its binary equivalent. Already you know the methods. And then this is in how much bit? 7. So you have to convert in which bit? 8 bit. Now this is a negative number. This is a negative number, you can see. So for negative numbers, I will take the first complement of this. So first complement of 67 is minus 67. It is nothing but the first complement of 0, 1, 1, 0, 0. This is 1, 1. So what is this value? You can say its value is 1, 0, 1, 1, 1, 1, 0, 0. So you can see here the first complement of 67 is what? Minus 67. So you find the complement of this. So first complement of this, what you can say? This is 1 is 0 is 1, 1 is 0, 1, 2, 3, 4. So you can write like this. So you can say the answer is for minus 67 is first complement number is given by this binary number. See, what is the question? Find the binary number for this negative decimal number. So what is the step I have to follow? Find its magnitude. Then find its binary equivalent. This is a binary equivalent. Now, this is in how much bit? 7 bit. In how much bit I have to write? 8 bit. So I have added 1 0 here. So this does not make the change. Don't add a here. You have to add here. Okay. Now this is your, this represents 67. But you have to write for what? Minus 61. So you have to take the complement of this. So first complement I have taken. So this represents minus 67. Now, so someone say I want to do for the 102. Let us do for the 102. So what is the way? Second, 102. This is a positive number. This is a positive number. So see, directly you can find the binary equivalent of 102 you can write directly. You can write directly. You can write means you have to do. I am writing directly. 110. So this is a binary equivalent of a, you can say, 102. You have to write in how much bit? How much bit? 8 bit. So what should I here how much bit? 1, 2, 3, 4, 5, 6, 7. 7 bit. So I have to add one more bit. I have to add 0 here. I am adding 0 here. So this is your 102 decimal number into binary number with the help of first magnitude representation. First complement, sorry, with the help of first complement representation. Now third you want to do, third is minus 88. So minus 88. Third is minus 88. So step 1, write its magnitude. So I have written magnitude. Step 2, find its binary equivalent. Finds its binary equivalent of this number. So binary equivalent of 82 is 1 0 1 1 triple 0 1 0 1 1 triple 0. So this is your binary equivalent. Now in how much bit we have to write? We have to write in how much bit? 8 bit. So look here, this you are getting how much? 1 2 3 4 5 6 7. So I have to write in a 8 bit. So 8 bit means what? I have to add here 0. So total is how much? You can say 8 bit. Now I have to first complement of this. So I can write first complement of 88 is minus 88, means from this I can write first complement of, this is your 0 1 0 1 1 0 0 0 is, so you can write like this. 0 is what? 1. This is 1 is 0 1 0 0 triple 1. So I think you understand what I did. See, minus 88. First I write magnitude. Second step, this converting a binary number. This is a binary number of this. You have to do yourself. Then you can do yourself. You already are familiar with this. Then I have written in a 8 bit. So first complement of 88 is minus 88. So find the first complement of this. So 1 is, this is 0 is 1, 1 is 0, and 0 is 1 0 like this. So this is nothing but the, you can say, your answer is, you can write 1 0 1 0 0 1 1 1. So this is your answer to represent this of minus 88 in a binary number. So we are discussing for negative number. Remember, this is for negative number, these are the steps. For positive number is the same as the sign magnitude representation method. I think you are getting the clarity here. Let us see the another thing. If you given the first complement representations, and you have to find is binary equivalent. Look here, suppose they have given like this: the following 8-bit binary numbers are in its first complement representation. Find its decimal equivalent. So what are the method? So I am discussing how to find this. First I am writing first 1 0 1 double 0 triple 1. Step 1, check sign of binary number. So you can see here, if I am checking this binary, so that is MSB is 1, therefore given binary number is negative. Step 2, find first complement of given binary number. So first complement of given binary number is 1 0 1 double 0 triple 1 is nothing but I can write this is 0 1 0 double 1 triple 0. Now step 3, find decimal equivalent of 0 1 0 double 1 triple 0. So let us find, this is your 2 raised to 0, 2 raised to 1, 2, 3, 4, 5, 6, 7. So 0 into 2 raised to 7 plus 1 into 2 raised to 6 plus 0 into 2 raised to 5 plus 1 into 2 raised to 4 plus 1 into 2 raised to 3 plus 0 into 2 raised to 2 plus 0 into 2 raised to 1 plus 0 into 2 raised to 0. So its decimal equivalent. So sign is negative. Therefore answer is minus 88. So this is nothing but you can say this is your minus 88. Binary number is given and this binary number is in a first complement representation. So I am checking first the MSB. MSB is 1. Yes, MSB is 1. Then it is your negative number. So this represents negative number in short. Now, then what is the second step? Find the first complement of this. So I find the first complement. What is the third step? Find its decimal equivalent. So I find the decimal equivalent. Now, second, and this decimal equivalent is how much I am getting? 88. What is the sign? Negative. So what is your answer? Minus 88. Now, let us do the second. This one. So, this is 0 1 second numerical 0 1 0 1 double 0 double 1. See you want to find 0 1 0 1 double 0 double 1. This is your binary number in a first complement representation. What is the step? First step, check sign Here MSB is 0, therefore given number is positive. Step 2. Find its decimal equivalent. So let us find its decimal equivalent. Once MSB is 0, no need to take the first complement. So I am finding this is your 1, 2 raised to 0, 2 raised to 1, 2, 3, 4, 5, 6, 7. See, this is your, so I can write 0, its decimal equal is 2 into 2 raised to 7 plus 1 into 2 raised to 6 plus 0 into 2 raised to 5 plus 1 into 2 raised to 4 plus 0 into 2 raised to 3 plus 0 into 2 raised to 2 plus 1 into 2 raised to 1 plus 1 into 2 raised to 0. So you will get your, this is 2 2s are 4, 6, this is your 64 plus this your 16 plus this your 2 plus 1. So I can write this is your, see sign is what? Positive. So what is your my answer? Answer is plus 83. It's very simple. Now, so if MSB is 0, no need to take this first complement, remember. Now let us do the third one. 1 0 triple 1 0 double 1. So let us find for this third one. Third, 1 0 triple 1 0 double 1. Find its decimal equivalent. This number is given in a first complement representation. They have given like this, remember. 1 0 triple 1 0 double 1. Let me check. 1 0 triple 1 0 double 1. Now, step 1. See, let us see the step 1. You know the step 1 again. Check sign. You can see us MSB is 1, MSB is 1, therefore number is negative. Remember this. Step 2. Find its first complement. So first complement of 1 0 triple 1 0 double 1 is nothing but the, you can write this is your 0 1 triple 0 1 double 0. You can check, this is double 0 1 0 like this. Step 3. Find decimal equivalent of 0 1 triple 0 1 double 0. So I can write 2 raised to 0, 2 raised to 1, 2. You can do directly. It is not a big thing. This is 2 raised to 0, 2 raised to 1. This is 4, 8, 16, 32, 64. So 64 plus 4, it is 68. So answer is minus 68, minus 68. So this is the way you can solve the numerical for a first complement representation method. I think you understand the how you can use first complement representation method to represent negative decimal number into binary number. For your more clarifications, let me do one more thing. Minus 27 representing a binary number in a sign magnitude representation. So you already know that in a 8 bit, remember 111011, okay, and your return 1100. This is your this is the way you can write in a sign magnitude representation with a 8 bit. Now same thing I am writing in first complement in a first complement representation 8 bit. So it will be written in this way. You can check your numerical second thing, plus 27 write in sign magnitude representation with 8 bit. So I can write 27 plus 27 in first complement representation 8 bit. So it is so you understand I am using this method to represent negative decimal number into the binary number. Here is the end of your lecture.